Tervetuloa Kalle's coding journey. Today it's time for week 3. In week 3 there were 2 different types. It was the mandatory and it was the 2 choice part. So the mandatory assignment was plurality, which is just a basic election thing. The person with the most amount of votes wins. Tideman, however, is very different. It has ranks and graphs and arrows, and I will try to explain later, but basically the person I'll explain later. We'll take it later. So let's just start with plurality. In plurality, you had two, let's say, functions to make, or there is 2 functions to make. The first one is vote, and it takes one argument called name, and it should see if the name is correct. Here is the code. And more the part or the function. So this one should take one name. It should see if the name matches any of the candidates you can vote for, and then it should add a vote to them. That's it. Then we have the print winner function, and here I will sort out and and see which candidate has the most amount of votes, and if 2 of them has the same amount of votes, I will print them both. So that's it. So let's just start the program. /plurality, and we can have candidate A, B, and C, and we can have 7 voters. So let's say A get 1 vote, B get 1, A get 1 again, and A get 1 again, and it's very popular. Oh, and here we see A wins with 4 votes, and that's it. So let's get through the code. The program that we download from the beginning already has functions to get the candidates list and makes a struct for the candidates and so on. Then it also allows me to vote. So I ask how many voters and so on. So that they have already fixed for me. And then we have vote and print winner. So the vote function, I first made a bool, is candidate, which is false. Just because, you'll see later. Then, to check if it actually is a candidate, I made a for loop. So I loop through all the candidates using the amount of candidates count, because we have that as well. So for each candidate, I do a string compare. So if the candidate I matches the name which I input, then it gets a vote, and now a candidate is true. If not, if the candidate doesn't get true, then I will return false. So it's simple as that. We can actually try it out. So here, let's say I have 1 voter, and I just doesn't type in A, B, or C. I type in F. Well, it's an invalid vote. That's it. Let's do part 2 then. The print winner function. Print winner should print out the name of the candidate who receives the most votes. And if it's a tie, each voter should be the winner, and on a separate line. So how did I do this? I have made it in 3 parts. The first part is finding out which candidate has the most amount of votes. And that vote, so loop through all the candidates. I check its votes against the index votes. So if I start at 0, 0, and let's take this for example, if I start at 0, which is index 0, so just compare with compare, then it will take, okay, the biggest one is index 0. Then we'll go to I1, which is the B. Let's see that 2 is lesser than candidate index. So it won't change the index. And then we would see that C is even lesser and it won't change the index there either. So the first part just matches the index with the biggest votes. The second part is to check if something is to make so that if somebody has the same amount of votes as the winner, so if it's a tie, they don't get debated out of the election. So here it also loops through each candidate and it checks if it has the same candidate votes as the index. And if not, they will have 0 votes. So now we know if they don't have 0 votes, they are tie or winner. And then it's simple. So for the last for loop, I just print everything that's larger than 0. Bam. That was plurality. Very simple, very straightforward. Then we have the hard one, Tideman. Let's put it up here. This one was a doozy, I can say. So Tideman. Well, so here it says you will make a program that implements the Tideman election. So here you say, see, for each voter, they can rank each candidate. So here we have Alice, Bob, and Charlie as the candidates, and I have 5 voters. So the first one ranks Alice first, Bob, 2 as Charlie, 3 as Bob, blah blah blah, and so on. And here you see Charlie is the winner. But why? Charlie is the winner because he doesn't have any arrows pointing at him. And what does that mean? Let's go down actually and show you in the video. I don't need to listen to him. Every time someone votes, a person gets a point for the person they win over. So here Alice wins over Charlie and Bob, and Charlie wins over Bob. So each vote is actually 3 points per se. So the first function is just to get the ranks. Okay, we take the functions later. So the program needs to figure out the ranks. So 1, 2, 3. Get the points for the correct ranks at the correct position. So the preferences. When it has that, it needs to figure out which pair. So which pair has the largest difference and put them in order. So if Alice wins over Charles by 7 points, or Bob wins over Charlie by 4 points, and Charlie wins over Alice by 3, then Alice has the greatest difference, then Bob over Charlie, and Charlie over Alice. The problem is, why you rank them is to then make the graphs up here. So we say that Alice wins over Bob with the biggest victory. You can actually see it by 72 margin. That's a lot bigger than a 5-4 between Charlie and Bob, and a 6-3 by Charlie over Alice. So first we draw an arrow from the largest margin victory. So Alice to Bob, you see here. Then we take the next largest, Charlie to Alice. And then we take the next, which is Bob to Charlie. But for it to be a Tideman voting system, you can't draw an arrow from Bob to Charlie, because then we'll arrow here, arrow here, arrow here, and it will be a circle. And because the margin from with the winner where Bob wins over Charlie is last in the descending order, it won't be drawn. And the winner of this Tideman election is the person that doesn't have any arrows pointing to it. So Charlie is the winner. That is how the Tideman works. Let's just show it off then. Let's see here. Tideman, we have A, B and C. And we can take an example from, let's see, from down here. We can take this one. I have ABC, which stands for Alice, Charlie and Bob. I have 5 voters. I vote for A, C, B is the first voter. Here you also see how I execute the points. Wait a second. Okay. That's not good. Video. Okay. Let's see later. You just see the ranks here. I will show later how it looks. Why doesn't it? I can actually turn it around like this and you will see. The first voter, I vote for Alice, Charlie and Bob. Then I would vote for Alice, Charlie and Bob again. Then for Bob, Charlie and Alice. Then for Bob, Charlie and Alice. And then for Charlie, Alice and Bob. And the winner is Charlie. Here I have a lot of stuff which I've printed out to explain the code. So let's do this. Let's move this to the side. And now I see everything. Almost. Okay, weird. Okay, I can't see my code in the bottom for some reason. So I guess I'll just do this. Now we can see. We have 5 different, or let's see here. Let's go down. We have 1, 2, 3, 4, 5, 6 different functions in this program. Let's start with the first one. The first one is vote. Here you need to rank, give a rank for the votes. So if let's go up here. So here I should rank A, C and B. So in the index it should be 0, 2 and 1. And if it's not, let's see here. If it's not a correct candidate, it will just say it's wrong and return it's not a correct vote. So let's check it out. First I have a for loop and I string compare for each candidate name, and if it's not equal to 0, it's wrong, and if it's equal to correct, it will place it at the correct rank, and then it will return as the function. So if wrong is too big, where wrong equals the candidate count, then wrong will return false. So basically it's just a system to make it say if it's false and otherwise give it the ranks. The next part is the record preferences. So here we go to the 2D array. The 2D array was very hard for me to figure out. And as you see, it's a lot of for loops and kinda messy. But I print a lot of stuff, so it's easy to see. So for the first vote, the preferences look like something like this. A, or I can actually explain the array. In the first line, it represents Alice, then Bob, then Charlie, then on the columns it's A, Alice, Bob, and Charlie. So if they rank Alice as number 1, she gets a point over Charlie, over Bob and Charlie, and Charlie gets 1 point over Bob. Bam. Quite simple in the theory, but hard for me to figure out how to code. So let's show here. First, I made a struct called rank index and rank value, and I made a list with them, or an array called information with the size of the candidate count. Then I made the array, so converting all the values from the ranks into this struct. Not that complicated. Then we have the very interesting for loop, which took me a long time to figure out. Very long time. So I have 2 for loops here, which just count through each row. So it will start at the first row and see Alice. Okay, Alice, what does she win against? Then I take G. So I will see information J, rank value. So if I equals information J, rank value, so what is J rank value? Well, then it will be the X at the index K. So if we go with J, then it would be 1 and 2. Because it will be, if I equals rank value, she is the rank 1, rank 0, so all the other ranks will get a vote. So everything that's not 0, 0 will get a vote because she's the first. So then I make this for loop to get in the votes. So for the candidates K, it makes another for loop, and it loops through the first index, and then it places a plus to the preferences where the rank value is. And then it does it for Bob, and it says it doesn't win over anything, and it does it for Charlie, and he just wins over Bob. That's it. Next part is print the 2D array to see what happens each voting return. The next part is to record pairs of candidates where one is preferred over the other. This was also quite confusing. At first I got the highest number, which I named x for some reason. So, and here I made 2 for loops because, well, it's a 2D array. So if x is larger than preferences, so the spot, so I get where the spot is the biggest, then x equals the preferences. Let's actually see here. I don't even think I use x. Yeah, I don't. Let's see here. I think this was some part which I used for fun. Let's make Tideman. Wrong. Okay, sorry. Candidates. I changed this part, so maybe it's also, so that could probably candidates count, of course. Candidate count. Oh, like that. So let's go back here, see if it just works. Let's vote like before. Alice, Charlie, Bob, Alice. Oh, 5 voters. Alice, Charlie, Bob. Just gonna check my other screen. Alice, Charlie, Bob. Looks correct. PCA, PCA, and CAB. It still works, great. This was just something I thought I needed. Let's keep that. Let's get to the thingy here. Here we need to make pairs. I made something called pair count equals 0. I made it so pair count is 0. And I make 2 for loops. So I can go through each, let's say, bracket or array. Yeah. So if the preferences are larger, we can actually see here. So if we go from I3, I0, 1 at this location, then I'll take the opposite position, which is 1, 0, and I see, oh, it's bigger. Then I say what is the winner and what is the loser. I add it to the pair count. This took me a little time to figure out, but after the first one, which was really hard for me to figure out, it went smooth. Then I just print the pairs for easiness. So if we take our old voting example, here here Alice wins over Bob, Charlie wins over Alice, and Bob wins over Charlie in descending order. So this is actually yeah, and now they are not in order, or kind of, but yeah. The next part was to sort the pairs, so I made another struct, and here I made and in there I have the difference. I had an index, I had winner and loser, and I call them differences, and the size is the pair count. And then I add the differences between each pair to see which has the largest difference. So from if Alice has 3 votes and Bob, if Alice has 5 votes over Bob and Bob has 3 votes over Alice, then it's a difference of 2. So that's what I want to find out. So I wanted to find the biggest difference and put them in descending order. And here I just transfer the information to my new struct. I print the differences and I now sort the pairs. So I make it for, because it's a 2D array, 2 for loops. And then I have this lovely thingy here. I have so if differences I difference is larger than j, then I will create some new things here. Whoops. So a equals difference I difference. Difference I with difference equals difference.j and blah blah. So actually I will just transfer it over to int a, b, c, d. That's what it is. Just copy it over to new values. And then I will just update the order in the difference array. So I will print the difference and update the order in the pairs array. And then I will print the new order. So let's see here. Here is the difference of pairs and here is the new order. So it went from the same, but now it's in order. The last part was to lock the pairs into the candidate graph. And this took me some time as well. Yeah, here I printed the blocked array for additional info. Yeah. So here it is trying to make it not go in circles. And first I have a loop, a bool found loop, which is false. And I have for loops here, 2 for loops, because it's a 2D array. And if locked z and k equals locked pairs I winner and pairs I loser, then if locked pairs loser and k equals true, I will go into another for loop, and if locked kf equals true, locked pairs I winner pairs I loser equals false, found loop equals true, print found loop. Else, if found loop equals true, continue. Else, locked pairs I winner pairs I losers equals true, find loop equals false. Continue, false. I feel like I forgot to delete something here, but the part here is if it will go through from the descending order, of course. So it will first go through and see and add the winners, the largest winners, and when it comes to and when it finds that something has an arrow to it from both directions, if one has an arrow pointing towards something and then against it again, creating a loop, it will just skip it. So that's what this part does. I probably need to remove something here. I will check up that later. Then we'll print the array. And the last part is to print the winner. And I make a for loop for the pair count, and if the locked pairs blah blah blah, winner loser equals false, then continue, and if it's true, and if int f equals blah blah, it will make another for loop, and if it's true, it will continue, else winner index equals I. So here it just figures out at which index the winner is placed. And as we know, Charlie is the winner. So here it just prints the winner, candidates pairs winner index dot winner. Bam, everything is perfect. Whew. Yeah, this one is a lot to go through, and I had took me like a week to figure out some parts. But then you learn a lot of 2D arrays and everything. It was amazing. But thanks you a lot for listening. Sorry it's a long one. Have a really good day. Adios.